Hello all. In this video we're going to look at defining the scalar resolute and vector resolute commands on CAS. So if we think about the scalar resolute, the formula tells us, as we've seen in class, that to find the scalar resolute of A in the direction of B, we take A dot B hat. So remember that B hat was given by the vector B divided by the length of B. Okay, so this is our scalar resolute here, and then our vector resolute for A in the direction of B was the scalar resolute times the unit vector B. Okay, so remember the unit vector gives us the direction that we're heading in. So to define first of all our scalar resolute, we want to first of all go to menu, actions, and remember we're going to go to the library and want to go to define libpub because we want to define these commands in our public library. Alright, so in the CAS guide I've called it the scalar resolute sres, so sres for scalar resolute, and we've got our two vectors A and B. So what we're going to do here is say our input vectors A and B. So we want to have, looking back at our formula, the scalar resolute was A dot B hat. So we're going to take the dot product. So we can find that in our vector menu, all the way into vectors, there it is, dot product. The dot product of A and B. We want B to be the unit vector B. So again, in our vector menu, we have this option here, unit vector. So the unit vector of B, and job done. Okay. So what this command is telling us is if we input two vectors A and B, it's going to take the dot product of A and B hat here. So when tackling or using this in a question, whichever one we're going in the direction of so in the direction of V, in the direction of Z, in the direction of W, that'll be our second input here. Alrighty, so now we want to define our vector resolute. So we want this scalar resolute times unit vector B hat. So what we can actually do here, we could go ahead and write it all from scratch. So first of all, we want to go to our define to actions library and define libpub for public library, and for the vector resolute, I'm going to call it vres, and our two inputs A and B. Now, rather than utilizing what we did before with the dot product of A and B hat, we recognize that we'll be working the scalar resolute here, and we've actually already defined that above with our command sres. So I'm going to be a bit lazy here and actually a little bit more, I guess, cunning in the way I define this and use our earlier work that we've actually just defined. So to bring up our prior command that we just defined sres, we can press the var button on our CAS, which brings up everything that's been previously defined. So I'm going to utilize the work we just made, sres, so our scalar resolute times the unit vector of B. So to get our unit vector command once again, we need to go to our vector menu and unit vector there. Okay, job done. So because we're defining these in our public library, we need to save this file in our public library. So just like a computer, we go to File, Save As. Right. Now, I'm currently in my documents, so I'm just going to go up one folder, which doesn't do anything. So scrolling down, aha, my lib. There we go. Now, remember, when we want to call a file or give a file a name, we're not allowed to have any spaces in the naming. So because I'm working with vectors, I'm just going to call this file vectors. and save as. Alrighty. So, and lastly, when working with the public library, I want to then go doc and refresh libraries. So now that when I go to my library, that book button, that catalog button, and press 6 on the CAS, I've got there now a vectors folder which has my two commands. Alrighty, so let's see these things in action now. So what I'm going to do is I'm actually going to insert a notes page. Because I find it actually easier and better working on a notes page with vectors rather than a calculator page, and we'll see why. So first up, let's go ahead and define two vectors. We can pick any two random vectors. So to do so, remember we need to insert a math box. So Control M, to get that perforated box. If we don't feel confident with that, then we can go menu, insert math box from there. So we saw last time to define a vector. Let's call a vector A. And then to get the assign command, control the template button to get that colon equals. And remember, for a matrix, we need the square brackets. So control open bracket on the CAS. So let's say we've got vector A, let's call it 1, 1. So 1, 1. So here A will be I plus J. Hit enter. Our matrix vector is defined. And now let's define another vector B. Right, again, control template button to get the assign command, and then control open bracket to get the square brackets. Let's say we've got the vector 3, 4. Alrighty, so now we're going to find the scalar resolute of A in the direction of B. What we can do is go to our library. We've got our vectors folder, and we can straight away just jump towards our scalar resolute command that we just made. Now we want A in the direction of B. Just don't mind me here for now. Just typing that into B. Oops, can't even spell. To be super clear, so A in the direction of B, we first want to put in A, B, and then hit enter, and thankfully I picked some nice numbers to get an answer of 7 over 5. If we wanted B in the direction of A, then again we'd get our scalar resolute command and then do B, A. So the direction we're going in is always going to be our second vector that we import. And we get a slightly more exotic answer of 7 root 2 over 2. Now the reason for doing this in the notes page is we've seen that it's quite dynamic, the notes page. So for example, I could have simply gone back to my initial line here and simply just swapped around B and A to get the answer. Or if I'm working on say question 1 and then question 2, I've got two different vectors. Maybe I've got a 2 here. Then if I press enter, it all updates automatically. And then likewise for the vector resolute, so if I wanted the vector resolute, then I can go to my menu, so my library, vectors, vres for vector resolute, and then A, B for A in the direction of B, and then there's my vector resolute. What you'll find with the CAS is that it puts in the scalar inside the matrix. So for example, if you're doing it by hand, what you'd normally expect in this instance would be something of the form, something like this. So you'd have, if you work it out, you get scalar resolute times the length of B, and you get that coefficient at the front, and then you've got the vector B there. So the CAS is really just putting that coefficient on the inside of our matrix. So if you want to leave the coefficient on the outside or leave it inside, both answers are perfectly fine. Okay. So hopefully that's helped, and as you work through the CAS project, you'll come across some other little interesting commands. So remember, if you want to add to your list of vector commands here, continually just update and save that in your library. And then I do implore you to work in the notes page when working with vectors. Okay.